Okay, so the first thing that we want to look at is multiplying. 2 times 3 is 6. Okay, that looks good enough.
Okay, what we're going to go ahead and talk about, we're going to talk about TEK 6.1a, comparing and ordering non-negative rational numbers. And that's going to come down to comparing fractions and also comparing decimals, and sometimes fractions and decimals together. So for the purpose of time, I'm going to go ahead and I'm going to narrow it down and talk about comparing fractions against other fractions. So I'm going to start with something very basic and very simple. We have the fraction 1/2. We have the fraction 3/4. We have the fraction 4/5. We are going to need to compare and order these fractions to find which has the greatest value and which has the least value. One of the most important rules for comparing and ordering fractions is they have to have the same common denominator. Going back to what we know about fractions, I'm going to show you the three fraction bars representing 1/2, 3/4, and 4/5. If you'll notice, all of these fraction bars are equal in size. However, they are not equal in the number of pieces. So this is 1/2. This is 3/4. And this is 4/5. Now bear with me because it might not be perfect, but it's the general idea we're looking for. 1, 2, 3, 4. Now, if we want to determine which of these fractions represents the greatest value versus the least value, it's kind of hard to do that because they're in all different sized pieces. So when we're finding the common denominator, what we're looking for is we're looking to find how many pieces we need to put each fraction into so that they are even pieces that we can compare. So I start here. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. 2 times 5 is 10. I'm going to go out to 5 and I'm going to stop right there and I'm going to move to the next one. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. Right there, I'm finding a common denominator between 4 and 5 of 20. So I'm going to go ahead and I'm going to see, can I find a multiple, or is 20 a multiple of 2? 20 is indeed a multiple of 2 because 2 times 10 is 20. So now we've determined that we will cut these fractions into 20 even pieces. That's what we're doing when we're finding a common denominator. So we have determined that our common denominator will be 20. That means each of these fractions are now going to be cut into 20 pieces. We do not change the value of the shaded piece, we just change how many pieces it is. So 2 times 10 equals 20. So each of these pieces I'm actually going to be cutting into 10 more pieces. One, two, three, four. 1, 2, 3, 4, 5. 6, 7, 8, 9, 10. And the same on this side. 1, 2, 3, 4, 5, 6, 7, 8, and 9, 10. And then again, it's not perfect because I'm not an artist, but it gives us the general idea. Here, we were going to take our 4 pieces and we were going to turn it into 20 pieces. Our rate of change there would be times 5 would equal 20. And that's essentially what we did here. We did times 10, that was 20, times 5, and that was 20. And so now we're going to cut each of these 4 pieces into 5 smaller pieces. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Again, not not perfect, but still giving our general idea. And once again, here we were going to 20 pieces. Our rate of change was going to be times 4 to give us 20. So each of these 5 pieces will be turned into 4 pieces. Or each of these 5 pieces will be again divided into 4 pieces. That's the correct way to look at that. And then what you'll notice, and if I had everything to scale and even, it would be much clearer that all of these pieces are now even in sizes. So it is now fair and appropriate for us to be able to measure the fraction that's representing the greatest value and the least value. So what we do on the top or on the bottom, so what we did on the bottom here, 2 times 10, we also have to do on the top. You'll notice now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 20 pieces, which is equivalent to 1/2. We have not changed the actual value of the shaded material. We have just changed the number of pieces. So once again, 4 times 5 was 20, which you do to the top, or the bottom, you have to do the top. 3 times 5 is 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, I made a mistake. 15. Okay. And finally, what we do to the bottom here, we have to do to the top over here. 4 times 4 would be 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It is now easy to compare and order the fractions 1/2, 3/4, and 4/5, 1/2, 3/4, and 4/5 by comparing their equivalent forms with common denominators, because we cut the pieces into equal sizes. 10 over 20, 15 over 20, and 16 over 20. The order of our fractions from least to greatest would be 1/2 is the least value, 3/4 is the next value, and 4/5 is the greatest value.